everybody, and welcome back to Jumanji. Today's question is, which of these two compounds have the strongest intermolecular forces of attraction? And this is a really good question because it requires a lot of basic but vital chemistry skill, right? The first thing, be able to differentiate among your four intermolecular forces of attraction. Your weakest being your dispersion or London forces, followed by your dipole-dipole, then your hydrogen bonding, then your ionic polar bonds, right? To be able to differentiate, again, electronegativity difference, that between C and H is a 0.4, making your CH bond non-polar, right? So we can rule out ionic polar bond. We can rule out your hydrogen bond as well, because we're missing hydrogen bonded to your big three, your fluorine, oxygen, and nitrogen. We can also rule out dipole-dipole because we ruled out ionic polar, right? There is no polar bonds here. So the force acting on these two molecules are your dispersion forces, right? So the strongest of the two will then be number one, because with dispersion forces, the surface area of the molecule matters. The more surface area the molecule have, the higher the boiling point, the higher the melting point, the stronger the intermolecular forces, right? And another skill to be to identify a normal alkane chain versus a branched alkane chain, right? And even though these two molecules have 6 carbon, this is an N-alkane or normal alkane, a hexane, right? And this here, we have a branched alkane. This is a 2,2-dimethyl butane, correct? If we draw them out, they would look like this. Here you have a branched versus a normal alkane, and your branched alkane will have less surface area for the molecule to react, therefore less intermolecular forces of attraction, or lower intermolecular forces of attraction.